All right, everyone. I think it's time to begin. Thank you again for joining us for this webinar. Just some quick housekeeping items before we get started. For anyone who has any questions, I assume you guys are familiar with GoToMeeting. There is a section to ask questions. Please enter your questions there and we will address those at the end of the webinar. Second item, this webinar will be recorded, which means we will have this available and distribute once this is complete. With that said, thank you again for joining us. We appreciate your time and we are excited to talk to you today about Google Cloud Platform. As you guys are well aware, Suitebriar is known for helping organizations transition to the cloud and transition successfully. The majority of you, we assume, have made that transition starting with G Suite. What you may not know is Suitebriar also has a GCP division, Google Cloud Platform division, and we're excited to talk to you about Google Cloud Platform and some of those services within Suitebriar that we can offer you. Agenda-wise, we're going to be touching on three high-level points today. The first, talking about why GCP, right? What are the key, most popular reasons for looking at GCP and for organizations to move there. Second, services within GCP, diving a little bit deeper, and also the SMB market and what services work well for the SMB market. And number three, drilling in a more deeper, is we're going to talk about the capabilities. And on the prior slide, what I failed to mention is Craig Margano, our CTO, is going to be presenting the majority of the presentation today, and myself, Ryan Burke, sales executive here, are excited to again have you guys join us. So with that said, this is the agenda. Please ask questions within the section here, and we're excited to get going. All right, so number one, GCP introduction. Why GCP, right? First and foremost, infrastructure modernization, right? Everyone wants to be up to date. Everyone wants the latest and greatest technologies to be able to do the most with their investment, right? Google is born in the cloud. They're known for their security. What you may not know is now you have this ability to also pay for what you use, which is really great. Data management. Google is growing more and more with their cloud footprint. So being able to spin up a VM throughout the country and also throughout the world is a huge advantage. And just like G Suite and what you guys are familiar with, you are going to be working with us because of our expertise, because of our relationship with Google, our certification, our access to Google, and with regards to support. We'll take what we've learned with G Suite and apply those same principles and success with GCP, and we're excited to talk to you a little bit more about that later on. And then, as I mentioned before, the SMB is a great market for GCP, and some of those popular services within GCP that are great for the SMB are just straight up cloud storage, right? Getting rid of that local file storage, NAS, SANs, anything that you have locally, and moving it up to the cloud. Virtual machines, right? Moving those up to the cloud, along with creating that serverless infrastructure, not dealing with hardware anymore, and also running cloud SQL servers as well. That said, we'll pass it over to Craig Margano to continue on with the presentation.
Yeah, hi everyone, and welcome. My name is Craig Margano, and I'm a Google Cloud architect here at Suitebriar. And today we're going to show you some of the things that are possible on Google Cloud Platform. We'll first start with an introduction about GCP resources and project management using the GCP Console. Then we'll jump into some of the core GCP services and their use cases. I hope you leave here today with a stronger understanding of GCP and how it can help modernize and transform your business workloads in the cloud. So let's get started. So prior to showing screens of what GCP looks like and how it works and what you can do there, it's important to first have a basic understanding of the core concepts that relate to the word resources on Google Cloud Platform. What are resources? Where and how are they used? Google calls this their GCP Resource Hierarchy, and this is what it looks like. The GCP Resource Hierarchy resembles the file system found in traditional operating systems as a way of organizing and managing entities in a hierarchy. Each resource has exactly one parent. The organization resource is the root node, under which all other resources are grouped. This provides central visibility and control over every resource that belongs to an organization. GCP users are not required to have an organization resource. A user acquires an organization resource only if they are also G Suite or Cloud Identity customers. The folders resource provides for a grouping mechanism on top of projects, allowing you to organize team projects. It's required to have an organization resource to use folders. The projects resource forms the basis for creating, enabling, and using all GCP services, managing APIs, enabling billing, adding and removing users, and managing permissions. At the lowest level, resources are the fundamental components that make up all GCP services. Examples of resources include compute engine, virtual machines, cloud storage buckets, app engine instances. The GCP Resource Hierarchy allows companies to map their organization onto GCP and provides for organization policies that are inherited throughout the hierarchy. So now that we understand a bit about resources, let's take a look at how they're managed within the GCP Console. The GCP Console provides a web-based graphical user interface that you can use to manage your GCP projects and resources. When you use the GCP Console, you create a project or choose an existing project, and then you use resources that you create in the context of that project. To access the console, sign into your Google account and navigate to console.cloud.google.com. Upon accessing this page, if you're following along, you may be prompted to agree to terms of service, typically seen with new or first visited personal non-org accounts. If you're following along and you see this, check the box that says agree and continue. After that, a getting started page will be shown if you don't have billing set up or haven't activated the free trial account. A little bit about the free trial account. When you create a new Google account and visit GCP's console, you have an opportunity to sign up for $300 of credit to play around and test GCP. You may notice this as a banner at the top of the console. Click on the home page to navigate to the dashboard. On the left side, you'll see a navigation menu showing a list of various links to resources and services. We'll talk more about these later. For a new account with no projects, the dashboard shows a message stating to select a project. Normally, this would be pre-selected with the last project you viewed and the actual dashboard shown. Next, click on the Select a Project drop-down located in the top blue bar right next to Search. A new dialog will appear, allowing you to select an existing project from a list. There's also a new project list link here for creating new projects. Click the new project link and you'll get a new project view, which just has a few fields. A project name, which is a friendly name or a label for your project. It's auto-generated initially and updatable at any time. A project ID, this is the project's globally unique identifier. It's also auto-generated initially and updatable only at creation time. Notice the error message that's shown in here. So when I created this one, for example, I chose to use Joe's first project. That, unbelievably or not, was taken already. So I had to put another character in there to get it by this. The last field is location, and here's where you choose the organization or folders, which we discussed earlier, as a resource in which the project should belong. And that's it. Click Create, wait a few seconds, and we'll see the actual project dashboard. So here it is. It's just that, a dashboard. It's a quick view of your GCP project's resource information. It provides within panels helpful views and shortcuts to GCP-related resources and activities. The dashboard is completely customizable through a Customize link in the top right corner. This allows you to show or hide or reorder the panels that you see. There's many panels to choose from, and you'll likely see more added over time. There's also an activity tab here, which shows the project's admin activity logs. The activity logs contain log entries for API calls and other administrative actions that modify the configuration of resources. For example, the logs record when virtual machine instances and App Engine applications are created and when permissions are changed. Okay, so now that we know about project creation in GCP and the resources available through the GCP Console, we're next going to talk about roles and permissions, a critical component for managing access to your GCP resources. GCP offers Cloud IAM, which is short for Identity and Access Management. It allows you to manage access control by defining who has what access for which resource. The link to IAM can be found in the left navigation. With Cloud IAM, you can grant granular access for members to specific GCP resources and prevent unwanted access to other resources. IAM lets you adopt the security principle of least privilege, so you grant only the necessary access to your resources. When an authenticated member attempts to access a resource, Cloud IAM checks the resource's Cloud IAM policy to determine whether the action is allowed. This is all accomplished through the use of roles and permissions. Permissions determine what operations are allowed on a resource, but you don't assign permissions to users directly. Instead, you assign them a role which contains one or more permissions. So a role is simply a predefined or a custom group of permissions. When assigning permissions in GCP, you're typically assigning predefined roles for the most common sets of permissions, like project viewer, billing admin. For more advanced permission requirements, custom roles are easily created and can be based on predefined roles. When you grant a role to a user, you grant them all the permissions that that role contains. So that's a pretty quick overview of Cloud IAM. It offers a very robust set of features and capabilities, and much more information can be found online. Just Google Cloud IAM. Okay, so now that we've covered most of GCP's administrative concepts, we'll jump into GCP services. In this section, we'll cover specific services offered by GCP, which are considered some of their core offerings. These are Google Cloud Storage for unified object storage, Google Compute Engine for virtual machines, serverless solutions with Google App Engine, Cloud Functions, and BigQuery, and Cloud SQL for managed SQL databases. Last, we'll finish with the Suitebriar client use case for the company capabilities. Okay, so let's get started with Google Cloud Storage. Google Cloud Storage is a service within the Google Cloud Platform that provides unified object storage for live or archived data. The type of data you would store in cloud storage is called unstructured data. Examples include email messages, word processing documents, videos, photos, audio files, presentations, web pages, and many other kinds of business documents. Because the data stores both the file itself and extra metadata about the file, it's referred to as object data instead of just a file. Objects stored in Google Cloud Storage are grouped into what's called buckets. Buckets are containers within the cloud that can be individually assigned to storage classes. Google Storage classes offer 4 storage classes. Google Storage offers 4 storage classes: multi-regional, regional, nearline, and cold line. All storage classes offer unlimited data, the same tools and APIs for data access and IAM access controls. We'll talk about buckets and storage classes, then review some common use cases for Google Cloud Storage. Buckets are the basic containers that hold your data. Everything that you store in cloud storage must be contained in a bucket. You can use buckets to organize your data and control access to your data. When you create a bucket, you specify a globally unique name, a bucket geographic location where the bucket and its contents are stored, and a default storage class. You specify location for storing your object data when you create a bucket. There's 2 primary location types. A regional location is for one specific geographical location, such as Virginia. A multi-regional location is a large geographic area, such as the United States, that contains at least 2 geographic places. Storage classes. Google Cloud Storage offers 4 storage classes: multi-regional, regional, nearline, and cold line. Multi-regional storage stores data in multiple data centers across the globe. and has a greater than 99.99% availability. It's suitable for companies that need to access data frequently, such as for website content and mobile application data. Multi-regional class data is stored in at least 2 separate locations, which improves availability. It costs 26 cents per gigabyte per month, depending on location. Regional storage stores data in one geographic location. Rather than spreading it out, it offers 99.99% availability and is best for compute, virtual machines, analytics, and machine learning workloads. When storage and compute resources are in the same region, Cloud Storage Regional provides high performance and availability. Regional storage is priced at 2 cents per gigabyte per month, depending on location. And one quick correction, I mentioned that that the multi-regional is 26 cents per month. That's actually 0.026. My apologies. Nearline storage is for customers who need long-term storage for data that users access less than once a month. It's best used for archiving data as well as backup and disaster recovery. And it integrates with third-party backup products from vendors such as Unitrends and Symantec. Nearline storage offers 99.9% availability and is priced at 1 cent per gigabyte of storage per month. There's a minimum storage period of 30 days and an early data retrieval fee of 1 cent per gigabyte. And lastly, cold line storage is for customers who need to store data they access less than once a year. It's mainly for archiving and DR. It requires a 90-day minimum storage duration and is the least expensive of the 3 storage tiers at 0.004 per gigabyte per month. There's an early data retrieval fee of 5 cents per gigabyte. Customers can integrate cold line with third-party backup and storage products, such as those from Veritas, Ignite, and NetApp. After you create a bucket, you can still change this default storage class to any class supported in the bucket's location. However, you can only change the bucket name and location by deleting and recreating the bucket. Objects are the individual pieces of data that you store in cloud storage. There's no limit on the number of objects that you can create in a bucket. Objects have 2 components, object data and object metadata. Object data is typically the file that you want to store in cloud storage. Object metadata is a collection of name-value pairs that describe the object. To support common use cases like setting a time to live for objects, archiving older versions of objects, or downgrading storage classes of objects to help manage costs, Cloud Storage offers an object lifecycle management feature. You can assign a lifecycle management configuration to a bucket. The configuration contains a set of rules which apply to current and future objects in the bucket. When an object meets the criteria of one of the rules, Cloud Storage automatically performs a specified action on the object. Next, we'll review some common use cases that involve Google Cloud Storage. There's many use cases for which Google Cloud Storage is an ideal candidate for your data storage needs. We'll talk about 3 popular use cases, which will hopefully relate to some of your workloads. Backup and archiving. Cloud Storage provides fast, low-cost, highly durable storage for data access less than once a month, perfect for reducing the cost of backups and archives while still retaining immediate access. It's typically something every organization needs to do. Users inadvertently delete files, computers are hacked, hardware and network failures happen, resulting in file corruption, and natural disasters strike. Through the use of the cloud storage classes Nearline and Coldline, organizations are able to implement and achieve a cost-effective backup and archive solution that is fast and reliable. Solutions are easily crafted to move data from regional to Nearline to Coldline buckets based on aging rules that you define. With this strategy, the cost for storage is minimized by taking advantage of lower price points between the different storage classes. This is accomplished using the object lifecycle management feature we discussed on the previous slide. Some examples are downgrading the storage class of objects older than 365 days to Coldline storage, deleting objects created before January 1st of 2013. Keep only the 3 most recent versions of each object in a bucket with versioning enabled. Another use case is workflow integrations. The most common use case for cloud storage is its seamless integration with your workflows running on Compute Engine, virtual machines, or many of the other Google services. Buckets are used to store, retrieve, modify, and delete object data through a unified API. A typical workflow may include a process to upload files to a bucket, a process to read from the bucket and do something with the file objects, perhaps import a CSV file into BigQuery for data analytics, a process to produce a report and copy it to the same or a different bucket for distribution. Cloud storage is especially well suited for storing application data, media content storage and delivery, streaming videos and music, and serving images. The last use case here is static web hosting. Yes, a cloud storage bucket may also be used to host a static website for a domain you own. Static web pages can contain client-side technologies such as HTML, CSS, and JavaScript. It cannot contain dynamic content such as server-side scripts like PHP. Your domain's DNS record may be updated with the CNAME record to map your domain to a cloud storage bucket with the same name, and you have an instant static website. All right, that's it for cloud storage. I hope we've painted a pretty good picture of what's possible with Google Cloud Storage. Next, we'll cover virtual machines on Google Compute Engine. Google Compute Engine lets you create and run virtual machines on Google infrastructure. It offers scale, performance, and value with no upfront investments. You can create an instance by using the Google Cloud Platform Console, the command line tool, or the Compute Engine API programmatically. Compute Engine instances run public images for Linux and Windows Server that Google provides, as well as private custom images that you can create or import from your existing systems. This includes custom Docker containers. When you create an instance in a project, you specify the zone, operating system, and machine type of that instance. You can also choose the machine properties of your instance, such as the number of virtual CPUs, the amount of memory, by using a set or predefined machine types, or by creating your own custom machine types. Public images are provided and maintained by Google, open source communities, and third-party vendors. By default, all projects have access to these images and can use them to create instances. Compute Engine offers many pre-configured public images that have compatible Linux and Windows operating systems. Windows images have an additional license cost for the operating system. Custom images are available only to your project. You can create a custom image from boot disks and other images like Docker containers. Then use the custom image to create an instance. Compute Engine offers a feature called Managed Instance Groups, which allows you to configure virtual machines to participate in a group. Managed instance groups offer features like auto-scaling, auto-healing, rolling updates, multi-zone deployments, and load balancing. The auto-scaling feature provides the ability to scale the number of instances up or down as traffic demands, and that saves you money since you only pay for what you use. Graphics processing units are available to add to your virtual machine instances. You can use these GPUs to accelerate specific workloads on your instance, such as machine learning and data processing. The Compute Engine provides a robust computing infrastructure, but you must choose and configure the platform components that you want to use. With Compute Engine, it's your responsibility to configure, administer, and monitor the systems. Google ensures that resources are available, reliable, and ready for you to use, but it's up to you to provision and manage them. The advantage here is that you have complete control of the systems and unlimited flexibility. So that's a quick overview of Google Compute Engine and virtual machines. We'll next review some common use cases for Compute Engine projects. Compute Engine instances serve a wide variety of purposes. Here's a few of the more common use cases. Web hosting. Do it yourself. You can use Compute Engine to design and deploy nearly any website serving system you want. You can use virtual machines to build your application much like you would if you had your own hardware infrastructure. Compute Engine offers a variety of machine types to customize your configuration to meet your needs and your budget. You can choose which operating systems, development stacks, languages, frameworks, services, and other software technologies you prefer. Install Apache, Nginx, IIS, Node.js, whatever you want, whatever you need. The easiest way to deploy a complete web serving stack is by using something called the GCP Marketplace. With just a few clicks, you can deploy any of over 100 fully realized solutions with Google Click to Deploy. For example, it's easy to set up a LAMP, Linux, Apache, MySQL, and PHP stack, or WordPress, Joomla, or Drupal from GCP Marketplace. The system deploys a complete working software stack in just a few minutes on a single instance. Before you deploy, GCP Marketplace shows you cost estimates for running the site, gives you clear information about which versions of the software components it installs for you, and lets you customize your configuration by changing component instance names, choosing the machine type, and choosing a disk size, for example. After you deploy, you have complete control over the Compute Engine instances, their configurations, and the software. Another common use case is application servers. Use Compute Engine to host custom and third-party applications, corporate APIs, a time tracking system, a CRM. The possibilities are endless. Lift and shift. Move your existing virtual machines to GCP to take advantage of lower costs and better performance. Development and QA environments, continuous integration and continuous delivery. Google Compute Engine provides an ideal platform for software development teams and QA teams. It's well suited for implementing continuous integration and continuous delivery systems like Jenkins, which is available in the GCP Marketplace. Google Cloud Source Repositories is a Git source code repository integrated with and available to every GCP project. It also a rich set of DevOps tools are provided by GCP. Tools like the Cloud SDK and Shell, Cloud Build, which is an alternative to Jenkins, and plugins or extensions for the most popular source code editors. And once again, many open source and third-party application servers are available through the GCP Marketplace and Click to Deploy. Some of these are free and some are paid. Installed from hundreds of pre-configured solutions, developer stacks, monitoring, security products, and much more. Okay, so that was Google Compute Engine in a nutshell. I hope it's pretty clear what Compute Engine is, virtual machines, and how you can use them to empower your organization. Next, we'll take a look at Google's serverless solutions. What exactly is serverless computing? Despite the name, it does not actually involve running code without servers. The name serverless computing is used because you don't have to purchase, rent, or provision servers or virtual machines for the back-end code to run on. Here's Google's definition. Serverless lets you write and deploy code without the hassle of managing the underlying infrastructure. It enhances developer productivity by helping focus on what matters the most, building great applications and abstracting away the rest. Zero server management, no upfront provisioning, auto-scaling to meet traffic demands, and paying only for the resources used are just some of the benefits of serverless computing. Google enables you to build and deploy functions or applications using a fully managed end-to-end serverless platform. Great. That sounds much more efficient than spending time and resources on managing machines, right? So let's talk about some of the popular services that GCP offers as a serverless platform. Cloud storage is listed here, but we'll skip over that, and since we've already covered it in previous slides. But you should know that it too is serverless. There's no creation of a machine or any infrastructure before we could create a bucket. Okay. First up, Google App Engine. What is Google App Engine, or GAE? Short answer, it's a platform to run your web applications on. More detailed answer, Google App Engine is a fully managed serverless platform for scalable web and mobile apps, allowing you to scale your applications seamlessly from 0 to planet scale without having to worry about managing the underlying infrastructure. With zero server management and zero configuration deployments, developers can focus only on building great applications without the management overhead. App Engine enables developers to stay more productive and agile by supporting popular development languages like Java, PHP, Node, Python, and .NET, and a wide range of developer tools. The focus becomes just on writing code. With capabilities such as automatic scaling up and scaling down of your application, fully managed patching and management of your servers, you can offload all of your infrastructure concerns to GCP. Choose to run your applications in a serverless environment without the worry of over or under provisioning. App Engine automatically scales depending on your application traffic and consumes resources only when your code is running. You will only need to pay for the resources you consume. So App Engine supports popular languages. It's open, flexible, and auto-scaling. It's fully managed and cost-efficient. But that's not all. Here's some additional features. Monitoring, logging, and diagnostics. App Engine features tight integration with Google Stackdriver, which gives you powerful application diagnostics to debug and monitor the health and performance of your application. There's also application versioning, which allows you to easily host different versions of your app for deployment, tests, staging, and production environments. Traffic splitting. Route incoming requests to different app versions. Do A/B testing, do incremental feature rollouts. And lastly, application security. Safeguard your application by defining access rules with the App Engine firewall and configuring support for SSL certificates on your domain. Okay, so that covers the overview for Google App Engine. Pretty impressive. Next, we're going to talk about a couple of the use cases. So you may be wondering when or why would I use Google App Engine? If it wasn't obvious from the preceding slide, App Engine is typically for you or your organization's custom code, your application, whatever that may be. It's especially attractive for new applications, which can be designed from the ground up to take advantage of modern cloud and serverless technologies. It would be slightly more complex, time and cost prohibitive to port an existing monolith system to App Engine. It certainly could be done, but you would probably need to rewrite the application anyhow. Some ideal candidates for Google App Engine are RESTful API servers, search engines, media and content delivery systems, web hosting, and really any application. Some noteworthy applications that run on Google App Engine include Snapchat and Khan Academy. So hopefully that gives you some idea of what's possible on the application side of serverless computing. Is there another side? Yes. If you break down an application to its most rudimentary levels, it all comes down to functions. Google Cloud Functions is event-driven compute, a serverless execution environment for building and connecting cloud services. With Cloud Functions, you write simple single-purpose functions that are attached to events emitted from your cloud infrastructure and services. Your function is triggered when an event being watched is fired. Your code executes in a fully managed environment. There's no need to provision any infrastructure or worrying about managing any servers. Cloud Functions is the simplest way to run your code in the cloud. It supports automatic scaling, high availability, and fault tolerance. It has no service provision, manage, patch, or update, and it charges only while your code runs. So unlike deploying a serverless application, Cloud Functions only require actual coded functions or methods to be created and deployed. The functions are coded in Node.js or JavaScript, Python, or Go languages. Pretty cool. All right, so let's talk about some of the use cases for Cloud Functions. Cloud Functions provides a connectivity layer of logic that lets you write code to connect and extend cloud services. Listen and respond to a file upload to cloud storage, a log change, or an incoming message. Cloud Functions augments existing cloud services by allowing you to address an increasing number of use cases with arbitrary programming logic. Instead of building one monolithic entity where every function is baked into one block of code, Cloud Functions allows you to prop up each function on its own. Do you have an intensive operation like upload, compression, or data interpretation? Create a function for that operation and invoke it only when needed. Cloud Functions is not good for all things, but here are some use cases it's perfect for. An API server. API servers are functions. The input is an HTTP request, and the output is an HTTP response. It's perfect for cloud functions. Background jobs, such as file processing or syncing with third-party APIs. Asynchronous workloads, like lightweight ETL, which is short for extract, transform, and load database operations, or cloud automations, such as triggering application builds. These no longer need their own server and a developer to wire it up. You simply deploy a function bound to the event you want, and you're done. Serverless does not mean that you take existing code and chop it up into functions to receive a lower cost and instant auto-scaling. Adopting a serverless approach means utilizing managed services and allowing the provider to handle base functionality of your service or application, then use cloud functions to act like the glue between those services to deliver business value. Okay, so that's it for Google Cloud Functions. And the next up for serverless is Google BigQuery. Google BigQuery is Google's fully managed, low-cost analytics data warehouse. It's serverless, so there's no infrastructure to manage, and you don't need a database administrator. Focus on analyzing data to find meaningful insights, use familiar SQL, and take advantage of a pay-as-you-go model. BigQuery is a powerful big data analytics platform used by all types of organizations, from startups to Fortune 500 companies. Storing and querying massive data sets can be time-consuming and expensive without the right hardware and infrastructure. Google BigQuery solves the problem by enabling super-fast SQL queries using the processing power of Google's infrastructure. Simply move your data into BigQuery and let Google handle the hard work. You can access BigQuery by using the GCP Console, a command line tool, or making calls to the BigQuery API. BigQuery is free up to 1 terabyte of data analyzed per month and 10 gigabytes of data stored. It maintains a complete 7-day history of changes, allowing for querying a point-in-time snapshot of your data. This allows you to easily revert changes without performing recovery from backups. BigQuery organizes tables into units called datasets. Tables are then created under a dataset. There are built-in tools which allow you to easily import, query, and export data. Instead of database permissions granted to you on tables within a traditional database system, Google BigQuery integrates with its Cloud IAM roles and permissions we discussed earlier. The same access controls apply here. An important aspect of operating a data warehouse is allowing shared but controlled access against the same data to a different group of users. For example, finance, HR, and marketing departments all access the same tables, but their levels of access differ. Traditional data warehousing tools make this possible by enforcing table row level security. You can achieve the same results in BigQuery by defining authorized views and row level permissions. Here's a couple screens that I put on this next slide. There's a couple screenshots of the UI in BigQuery. The one on the left is showing an import of a CSV file from a Google Cloud Storage bucket. Options to import from, with option to import from Google Cloud Storage, Bigtable, Google Drive, or an uploaded local file. The second screenshot there is showing after the import was completed, and it's showing the query editor and the resulting data. You have powerful SQL analytics here. You can query and examine millions of records in seconds. There's options to explore this data in Google Data Studio for data visualization and reporting, or export it to Google Cloud Storage for further processing. Some use cases for BigQuery: data warehouse, data lake. We've talked about this a bit already. BigQuery actually replaces the typical setup for a traditional data warehouse. It serves as a home for all analytical data in an organization. Data lake is a term to describe the incorporation of data from disparate, different types and sources of data sources, and the retaining of all of its data into your data warehouse solution. Your data lake might contain files from cloud storage or Google Drive, or even transaction data from a database. BigQuery can also define a schema and issue queries directly on external data as federated data sources. A federated data source is one where the data stays in its original location, such as a Drive spreadsheet, but BigQuery is still able to fetch and use that data for queries. Data analytics. For analytics, BigQuery allows you to analyze what's happening now by making your latest business data immediately available for analysis. Get insights from your data faster without needing to copy or remove it. Google BigQuery gives you a full view of all of your data. Data visualization tools can help you make sense of your BigQuery data and help you analyze the data interactively. You can use visualization tools to help you identify trends, respond to them, and make predictions using your data. Google offers Data Studio to meet this need, and it is well integrated with BigQuery. And lastly, streaming data ingestion. Google BigQuery allows you to load data by streaming live data one record at a time. It's typically used when you need the data to be immediately available. And that's it for Google BigQuery. Next, we'll talk about Google Cloud SQL. Cloud SQL is a fully managed database service that makes it easy to set up, maintain, manage, and administer your relational Postgres and MySQL databases in the cloud. It offers high performance, scalability, and convenience. It's hosted on Google Cloud Platform. Cloud SQL provides a database infrastructure for applications running anywhere. It is not serverless. Cloud SQL is easy to use. It doesn't require any software installation. It automates all your backups, replication patches, and updates while ensuring greater than 99.95% availability anywhere in the world. It delivers high performance and scalability with up to 10 terabytes of storage capacity, 40,000 inbound, outbound operations per second, and 416 gigabytes of RAM per instance. Easily configure replication and backups to protect your data. Go further by enabling automatic failover to make your database highly available. With Cloud SQL, your data is automatically encrypted. Data is encrypted automatically in real time prior to writing to storage and decrypted when read from storage. As a result, hackers and malicious users are unable to read sensitive data from tablespace files, database backups, or disks. Cloud SQL offers per-second billing, automatic sustained use discounts, and instance sizes to fit any budget. Database instances are easy to stop and start. There's no upfront commitment, and with sustained use discounts, you'll automatically get discounted prices for databases that run continuously or 24/7. Cloud SQL is perfect for WordPress sites, e-commerce applications, CRM tools, and any other application that's compatible with MySQL or PostgreSQL. Okay, so that concludes our GCP resources and services overview. In this last section, we'll present one of the solutions Suitebriar provided to one of our clients, Meet Capabilities. Capabilities, LLC, was started by former education teachers in 1997. Today, they employ staff of over 160 employees that serve the people in the state of Ohio. Capabilities specializes in habilitation services for people with disabilities. Their services include a focus on community employment, community integration, driving services, career consulting, training, and education. Each month, Capabilities receives thousands of authorization forms from the state of Ohio. These authorizations are for state approvals of expenses related to the care of their clients. The authorization forms are PDF files, which are attached and sent to Capabilities through email at the beginning of the month. Attempts to extract form field data from these PDF files required a very manual and time-consuming process. They had an existing tool to help them, but they didn't own the code. It was buggy, lacked features, and it didn't perform well. Capabilities wanted to replace this tool with a new solution that utilizes modern cloud technologies. Capabilities is an existing Suitebriar G Suite client, so they reached out to us to inquire about a solution that can load their PDF files, extract the fields they need, and store them in a database for analytics and reporting needs. In the form, they were only interested in certain fields like number, name, participant ID, total, and instructions, which you may see in the screenshot there. Suitebriar met with members from the capabilities team to conduct discovery analysis and requirements identification. That was closely followed by design, development, testing, and delivery. The solution was designed by our cloud architects to load the PDF files into a Google Cloud Storage bucket each day. A custom application will then automatically fetch and process the PDF files, extract and required fields from the forms it finds, and store those as records in a database. The data now in a database, many tools are available to perform the analysis and reporting that are required. For the design, Suitebriar consulted with capabilities to agree on the eventual solution as shown in the image. Google Cloud Storage is used for holding and organizing the PDF files in a bucket. This is a manual process as they are received over email and the client did not want to automate it. Compute Engine is used for a simple LAMP stack, Linux, Apache, MySQL, and PHP, and to run a custom software application, a Python application we call PDF Processor. This application loads PDF files from the bucket, extracts required fields, and inserts them as records in the database. To extract the fields, we chose to utilize the Google Cloud Vision API, which is a machine learning API abstraction. We use it to perform OCR and receive the resulting extracted text. MySQL was utilized to take advantage of a fully MySQL database used for analytics and reporting. Google Cloud SQL could have just as easily been used instead of the MySQL instance locally installed with the LAMP stack, but the client requested control and use of the local MySQL instance. Backups are performed nightly and are additionally copied to the Google Cloud Storage bucket. Apache Web Server, the A in the LAMP stack, gave them a platform to easily create and serve pages in PHP that query and display the authentication form data. And Google Source Code Repository is a cloud-based Git repository for managing their source code. Development testing. Suitebriar's development team prototyped several options before deciding on a final decision. For example, several different technologies for the text extraction portion were tested before finally deciding to use the Cloud Vision API with OCR for its text detection accuracy. Suitebriar worked closely with capability staff to discuss concepts and issues that require business logic decisions. For auditing and issue resolution, any errors encountered while parsing a PDF document are stored in the database with details about the error. A scheduled task was created to invoke the PDF processor to check for new PDF files every X or predefined number of minutes, which is configurable. Testing was conducted through software development, resulting in early identification and resolution of issues. Delivery of the final product included the following. Documentation. We provide clear, detailed handoff documentation, which contains a start-to-finish guide on what was done and how to manage your solution. Source code is provided through Google's source code repository, available to every GCP project through the GCP Console. Scripts were delivered to automate the recreation of the environment from scratch if that was ever needed. Scripts are also delivered to automate the installation of the custom software from their cloud source repository. And last, provisioning of the GCP resources within the GCP project, the compute engine, network configuration, setup of cloud IAM. Finally, a scheduled go live was set to use the new process. As a result of this solution, capabilities realize significant savings on IT process management infrastructure, improved support for the disabled community through a streamlined case management process. They eliminated data redundancy, enhanced digital and data integrity. They've increased their caseload capacity and replaced cumbersome case management processes. Capabilities can now swiftly process PDF documents and store form information in the MySQL database for daily case management and future reporting. A quote from Tim Smith, who's the IT manager at Capabilities. With Google Cloud Platform Suitebriar, we're able to create an affordable custom cloud solution that we can use to significantly improve the efficiency of our core product. And that, folks, is the end of our presentation. I do want to thank you for attending, and I really hope you gained a broader understanding of GCP, its services, and the services that Suitebriar can provide to help your business. If you're interested in learning more about GCP for your business, feel free to contact Suitebriar today.
Great, thank you, Craig. That was awesome, very informative. I'm just going to take a look here at our questions. All right. Doesn't look like we have any at the moment. Again, if you have questions, feel free to enter those into the GoToMeeting question platform, and we'll answer them now. We'll give you about 1 more minute. Okay, Craig, we do have one question from Ronald, it looks like. Do you have any suggestions for cost savings for cloud VPN across multiple projects?
Is that question where I can read? Can you restate that actually, or repeat it?
Do you
I see it. I see it. Sorry.
Okay. Do you have any questions for cost savings for cloud VPN across multiple projects? Thanks, Ronald.
Yeah, but not off the top of my head. That's something that I'd like to look into and give you a more informative answer, if that's okay. If you want to collect his, we have your email address, right? We can send him a note.
Yes, definitely.
Yeah.
All right, on that note, thanks again for attending, and Craig, thanks for presenting on this subject matter. It was very informative. Again, we'll have the recording out to you tomorrow, if not on Monday. Thanks again for your time.
Yep, thank you, everyone.
Okay, bye.